Welcome to my channel, viewers. Here we will discuss a few more sums on parallelogram. Earlier we discussed the properties of parallelogram, right? In a parallelogram, opposite sides are equal, AB equal to CD and AD equal to BC. Opposite angles are equal, angle A equal to angle C, angle B equal to angle D, and diagonals bisect each other. So if you join the diagonals, say their point of intersection is O, that means AO equal to OC and BO equal to OD, right? So these are the basic properties of parallelogram. So if in a quadrilateral you can prove that diagonals bisect each other, that means it is a parallelogram. Or if in a quadrilateral you can prove that opposite angles are equal, it is a parallelogram. If opposite sides are equal, then it's a parallelogram. Then we find that in a rhombus is also a parallelogram in which all sides are equal. Then we prove that in a rhombus, diagonals bisect each other at right angles. That means this part equal to this part, this part equal to this part, and angle between the diagonals is right angle, right? Diagonals bisect each other at right angles. Then we find that in a rectangle, diagonals are equal. A rectangle is a parallelogram in which one angle is right angle, right? It's a parallelogram in which one angle is right angle. One angle right angle means all angles are right angle, because in a parallelogram opposite angles are equal. So these two angles are 90 degree. Again, in a parallelogram, a linear pair is adjacent angles are 180 degree, right? So this angle plus this angle 180 degree. So if it is 90, then it is also 90 degree. An adjacent pair is 90 degree. So this plus this 90, so this equal to 90, right? So in a rectangle, all angles are 90 degree. That means in a parallelogram, if one angle is 90 degree, then all angles are 90 degree. Then in a rectangle, one additional property is diagonals are equal, right? That means BD equal to AC, right? You can consider these two angles, say ABC. So it is ABC and DCB, right? DCB. Now you find that AB equal to CD. They are opposite sides of parallelogram. Rectangle is also a parallelogram, so opposite sides are equal. Then BC equal to BC, common side, right? BC common. Then this angle 90 degree. So these two triangles are congruent by SAS congruence criteria, side angle side. Now if they are congruent by virtue of CPCT, corresponding parts of congruent angles are equal. So AC equal to BD, right? Since these two triangles are congruent, therefore corresponding parts of congruent angles are equal. So AC equal to BD. That means diagonals are equal. Now we will discuss a few more sums on parallelogram. So let us start with question number 1. If diagonals of a parallelogram are equal, then show that it's a rectangle. So you are given that in a parallelogram, diagonals are equal. So you are given that, say this is one diagonal, ABCD is a parallelogram, diagonals are equal. We are given that AC equal to BD, right? So given ABCD is a parallelogram, right? And AC equal to BD, diagonals are equal. to prove that ABCD is a rectangle. Now, how will you prove ABCD is a rectangle? When can you say a parallelogram is a rectangle? If you find one angle is 90 degree, that means it is a rectangle, right? So let us prove this. Let us try to prove this. You are given that AC equal to BD. AC and BD are equal, right? AC and BD are equal. Then you consider this triangle, say triangle ABC and DBC. In ABC, triangle ABC, you see AC AB equal to CD, BC equal to, BC is a common side, AC and BD are equal. That means triangle ABC and DCB are congruent triangle. This is triangle ABC and this is triangle DCB. You are given that AB equal to CD. Why? They are opposite sides of parallelogram, right? Is AB equal to CD. BC is a common side here, and diagonals are equal. You are given AC equal to BD. Therefore, these two triangles are congruent. If they are congruent, corresponding parts are equal. That means angle B equal to angle C. Now, sum total of angle B and C is 180 degree. In a parallelogram, a pair of adjacent angles are supplementary. So angle B plus C 180 degree. Since they are equal, so angle B equal to angle C equal to 90 degree. That means ABCD is a rectangle. Because we proved that one angle is 90 degree. At least one angle is 90 degree. In a parallelogram, if one angle is 90 degree, then it's a rectangle. So in triangles ABC and DCB, these two triangles, AB equal to CD, opposite sides of parallelogram, right? Then BC equal to BC, common side. Then AC equal to BD. This is given, right? AC equal to BD is given. Therefore, triangle ABC congruent to triangle DCB by SSS criteria. SSS congruence criteria means if three sides of one triangle are equal to three sides of another triangle, then they are congruent. Now in congruent triangles, corresponding parts are equal. Therefore, angle ABC equal to angle DCB, CPCD. Corresponding parts of congruent triangles are equal. Angle ABC plus angle DCB equal to 180 degree. A pair of adjacent angle in a parallelogram, right? A pair of adjacent angles in a parallelogram are supplementary. Now ABC and DCB are equal, so we can write twice of angle ABC equal to 180 degree. That is angle ABC equal to 90 degree. That means we prove that in a parallelogram, one angle is 90 degree. Since one angle of parallelogram ABCD is right angle, ABCD is a rectangle, right? So this has to be proved. This we are writing in short form parallelogram. So since one angle of this parallelogram is right angle, so it is a rectangle. Now we'll come to question number 2 here. So that diagonals of a square are equal and bisect each other at right angles. So let us draw a square here. So it is ABCD. It is a square. The diagonals of a square are equal and bisect each other. Let us draw the diagonals here. We already proved that diagonals of a rhombus bisect each other at right angles. Since a square is a rhombus, so it will satisfy the properties of rhombus. So it is obvious that diagonals will bisect each other at right angles. Still we are trying to prove it. So you are given ABCD is a square. What is a square? In a square, it's a rectangle in which one angle is 90 degrees. That means ABCD is a square, means all angles, angle A, B, C and D are right angles here. Now AC and BD intersect at O. To prove, what is to be proved? We have to prove that AO equal to OC, BO equal to OD. Then we have to prove that AC perpendicular to BD. That means diagonals are perpendicular to each other. So let us prove this. So we have to prove that this angle is right angle or this angle is right angle, right? So let us consider these two triangles. Since it is a square, AB equal to AD, right? Then AO is a common side here. Then BO equal to OD. Since in a parallelogram, diagonals bisect each other, so obviously BO equal to OD, right? So we can prove that in triangles A, O, B and A, O, D. Let us consider these two triangles. What things are equal here? AB equal to AD. Why? Since ABCD is a square. ABCD is a square. So all sides are equal. That means AB equal to AD. AO equal to AO, common side. Common side. Then BO equal to OD. Why? Diagonals of parallelogram. Diagonals of a parallelogram bisect each other. Since square is a parallelogram, so diagonals must bisect each other. That means BO equal to OD. Therefore, we find that three sides of this triangle are equal to three sides of this triangle. So they are congruent. triangle AOB congruent to triangle AOD by SSS criteria. Right? Now, if these two triangles are congruent, then corresponding part cycle, therefore, angle AOB equal to angle AOD. Cpct, corresponding parts of congruent angles are equal. Now, angle AOB plus angle AOD 180 degree. Why? It's a linear pair. Angle AOB and angle AOD. It's a linear pair. Therefore, we can write here AOB and AOD are equal. So we can write here AOB plus angle AOB equal to 180 degree. Right? AOD equal to AOB. So we are replacing this with AOB. This we can write here twice of angle AOB equal to 180 degree. That means angle AOB is 90 degree. Therefore, if AOB is 90 degree, that means AO perpendicular to BD, right? That is, if AO is perpendicular to BD, that is AC perpendicular to BD, right? So this has to be proved. That means diagonals bisect each other at right angles. Diagonals bisect each other in this case. Obviously, it's a parallelogram. A square is a parallelogram, so diagonals must bisect each other. Only one thing we have to prove here is they bisect each other at right angles. That means angle between them is 190 degree. We find that angle AOB is 90 degree. That means AO perpendicular to BD, that is AC perpendicular to BD. Now we are coming to question number 3 here. ABCD is a parallelogram. Diagonals BD bisects angle B. That means these two angles are equal. Prove that BD bisects angle D. That means these two angles are equal. We have to prove. So you are given ABCD is a parallelogram, right? Angle ABD equal to angle CBD, right? Given. To prove that angle ADB equal to angle CDB, we have to prove this. Now let us consider these two triangles. You find that here AD equal to BC, opposite sides of parallelogram. Then you find AB equal to CD, opposite sides of parallelogram, right? Then you find BD is a common side. So these two triangles are congruent, right? So we find that corresponding parts of congruent angle cycle. So these two angles are also equal, corresponding parts of congruent angle CPCD. Or you can use the another tricks here. AB equal to CD, then BD is a common side, BD equal to BD, right? And you are also given that these two angles are equal. So you can use this clue. These two angles are given equal here. So these two angles are equal. This side is a common side, right? Then you find that these two angles are equal, opposite angles of parallelogram. So by angle side angle ASA congruent criteria, you can prove that these two triangles are congruent. So we will use that trick in triangles ABD and ACD. BD. Let us consider these triangles. You are given that AB equal to CD. Why? Opposite sides of parallelogram. Opposite sides of parallelogram. Right? AB equal to CD. Then you find AB equal to CD. These two angles are equal. Angle BAD equal to angle DCB. BAD equal to CBD. CBD. Given. This was given condition, right? Then you find angle BAD. Sorry, you should write here ABD. 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 Then you find BAD equal to angle BCD. Opposite angles of parallelogram. Right? So we find that in these two triangles, let us separate out these triangles. One triangle is this A, B, D, and another triangle is this D, C, B. So you find that these two angles are equal. This angle equal to this angle, right? Then you find AB equal to CD, opposite sides of parallelogram. So these two triangles are congruent. Therefore, triangle ABD congruent to triangle CBD. Right? Why? Angle, side, angle criteria. Right? These two triangles are congruent. Therefore, in congruent angle, corresponding parts are equal. So these two angles are equal. Therefore, angle ADB equal to angle CDB, CPCD. Corresponding parts of congruent angles are equal. Right? So we proved that is BD bisects angle D. Angle ADB equal to CDB, that means diagonal BD bisects angle D of the parallelogram. So this has to be proved. Now we are coming to question number 4 here. ABCD is a rectangle in which diagonal AC bisects angle A as well as angle C. So that ABCD is a square. Since we have to prove ABCD is a square, so we are making a drawing of the square. So let us say this is ABCD vertex, right? ABCD is a rectangle in which diagonals AC bisects angle A. So let us join the diagonal here. It says these two angles are equal, right? As well as angle C. That means these two angles are equal. So that ABCD is a square. So when can you say a rectangle is a square? A rectangle will be a square when you find that all sides are equal, right? Normally in a rectangle, one angle is right angle, right? So we have to prove that a rectangle can be a square. Rectangle will be a square when all sides are equal. So we will try to prove this. So we will assume that it's a rectangle only at first. That means opposite sides are equal only first, but one angle is 90 degree, that we will have to consider here. So given that ABCD is a rectangle, right? Angle BAC equal to angle DAC. It is given angle BCA equal to angle DCA. This is also given. To prove ABCD is a square, that is AB equal to BC equal to CD equal to AD. Right? So we have to prove this. Let us prove this now. Now consider these two triangles first here. You find that these two angles are equal. Again, these two angles are equal. AC is a common side. Yeah. So these two triangles are congruent. Now in congruent triangles, corresponding parts are equal. So corresponding parts are equal means here side opposite to this angle is this, and side opposite to this angle is here this, right? So they are equal. That means if they are equal, this side is equal to this side, that means these three sides are equal. Again, this side equal to this side, that means all sides are equal. So that it would be a square. So we consider in triangles ABC and ADC. Let us consider these two triangles. We find that angle BAC equal to angle DAC given. Right? This was the first condition. BAC equal to DAC. This diagonal bisects angle A. These two angles are equal. AC equal to AC, common side. AC is a common side for both triangles. Then you are given that angle BCA equal to angle DCA given. Therefore, triangle ABC congruent to triangle ADC. Right? By which criteria? Angle, side, angle. ASA. This is the criteria. Now, if these two triangles are congruent, then corresponding parts are equal. Now, how will you find corresponding parts? Say, for example, these two angles are equal, so they are opposite sides are equal. So, what is the opposite side of this angle? AD. AD equal to, what is the opposite side of this angle? AB. AD equal to AB. And these two angles are equal, they are opposite sides are equal. So BC equal to opposite side of this is CD. BC equal to CD. CPCD. Corresponding parts of congruent triangles are equal. Now, since it is a rectangle, that means it is a parallelogram. Opposite sides are equal. Since AD equal to BC, right? Therefore, AD equal to AB equal to BC equal to CD. Right? Since AD equal to BC, therefore AD equal to AB means AD equal to AB equal to BC. Again, BC equal to CD, that means all sides are equal. Therefore, ABCD is a square. Since in this rectangle we prove that all sides are equal, so it is a square. A rectangle will be a square when you find that all sides are equal. So here we first prove that AD equal to AB by virtue of CPCT. Then we prove that BC equal to CD, but AD equal to BC. AD equal to BC, why? Opposite sides of parallelogram. Right? AD equal to BC, opposite sides of parallelogram. So BC equal to CD, AD equal to BC, AD equal to AB, here CPCT, BC equal to CD, CPCT, but we find that AD equal to BC, opposite sides of parallelogram. So AD equal to AB, this was the condition first, AD equal to AB equal to BC, and BC equal to CD, therefore BC equal to CD, that means all sides are equal, that is ABCD is a square. Okay, thank you viewers for watching this video. Hope you enjoyed these sums. We will discuss a few more exercises in the next class again.